Okay, let's try this again. Common Core Algebra 2, 3.5 Inverses of Linear Functions. Hopefully you can hear me this time. Technology has not been my friend lately, so hopefully it's going to start working now. So recall that functions have inverses that are also functions if they are one-to-one. With the exception of horizontal lines, all linear functions are one-to-one and thus have inverses that are also functions. In this lesson, we will investigate these inverses and how to find their equations. So, exercise 1. Let's slide this up a little bit. Basically, we're talking about, given the line y equals x, which is there in yellow. Try to keep it different from the other one. So, on the grid below, the linear function y equals 2x minus 4 is graphed along with the line y equals x. So this one I did in yellow so it's easier to see. How can you quickly tell that y equals 2x minus 4 is a one-to-one function? Well, I shouldn't have to tell you this. You should be able to write this down. So pause it, write it down. How do you know that so quickly? Hopefully now you are able to say, I was able to tell y equals 2x minus 4 is a one-to-one function because I was able to perform the horizontal line test, which it passed with flying colors. Okay, so B says graph the inverse of y equals 2x minus 4 on the same grid. So basically what we do is we consider the points values here, x and y. And let's pick some of these points. Let's pick the easy ones. How about this one down here, which is 0, negative 4. And this one here, which is 1, negative 2. And this one right here, which is 2, 0. And we just flip-flop them. So this way, this is the function y equals 2x minus 4. So the function of its inverse will be negative 4, 0, will be 1, negative 2, and will be 0, 2. Oh, and I still made a mistake. I didn't flip them, just wrote it down. So this is negative 2, 1, and this is 0, 2. So plot those points. 0, 2, negative 2, positive 1, and 4, 0. Negative 4, 0. So if I follow this same pattern up, I should be here, I should be here, I should be here. Following it down, I get here. You take a straight edge, or in my case, I can take my handy dandy line maker and plot my point. Plot, graph my lines. All right. What can be said about the graphs of y equals 2x minus 4 and its inverse with respect to the line y equals x? Think about that for a second. Trying to remember a few things from geometry last year and thinking about reflection lines, we can think as we go up here, up positive 3 from this point, left positive 3, that gives us a point right here. This one goes up 4 to the line y equals x, over 4 gives us this point. This one goes up 3, up 2, over 2 gives us this point. Too much. All right, so take a moment, write down how it's a reflection over the line y equals x before we move on to letter D. Find the equation of the inverse. Well, simply looking at our line right here, we know it's y equals mx plus b. So it's y equals, the y-intercept is positive 2, and the slope is 1/2 x plus 2. Up 1, right 2. That was easy enough. Sure you didn't need my help to do that. As we can see from part D in exercise 1, inverses of linear functions include the inverse operations of the original function, but in reverse order. All right, this gives rise to the simple method of finding the equation of any inverse, simply switching the x and the y variables in the equation. So in this example, we have y equals 5x minus 20. So if we just take our original and we switch it, because we're asking to find the inverse, so we say x equals 5y minus 20. Now, the one thing I'm going to do is I'm going to flip-flop because I'm old school and I like having my variable that I'm solving for on the left-hand side. And because equality is symmetric, we can just flip-flop them. All right, so now I'm going to solve this for y. So add 20 to both sides. 5y is equal to x plus 20. Of course, we cannot add those two. They're not like terms. And divide everything by 5. Now, the reason I do it like this and not just the way where you divide the whole side by 5. In other words, some people do this. 5y is equal to x plus 20. Divide by 5. And some people do this. Divide the whole thing by 5, which is mathematically equivalent to what I'm doing on the right-hand side here. But I do it this way because I don't want you to forget that when you divide by 5, that means that we have to divide this by 5 and this by 5. So if I do it like this, it kind of just keeps my operation straight. So y is equal to, now remember, you're going to pull this number out in front of the x to create a slope, and there's a 1 hiding here. So 1 over 5x plus 4. So the correct answer is number 4. All right, so pause, write down what you need to before we move on to exercise 3. All right, so this is a very simple procedure, but with fractions involved, things get a little sticky. So let's just take a look quickly at y equals 2/3 x plus 8. And again, the first thing we're going to do is we're going to flip-flop the x and the y, and x equals 2/3 y plus 8. And I'm going to flip it around again, because you know me, I like having that y on the left-hand side, minus 8 from both sides. 2/3 y is equal to x minus 8. And now we're going to multiply through by 3, right? So if you multiply through by 3, or you can multiply through by 3 over 2, lots of different ways to approach this question, all right? So when you do this, this becomes y is equal to 3 over 2x, and when you multiply 3 over 2 times 8, you get minus 12. So the correct answer is right here at number 2. Okay, how I solved that one probably wasn't the easiest for you, so let's take a look at exercise 4, and we'll try and do that a different way. So let's take right away, we'll say x equals, let's flip the x and y, 3 over 5y minus 9. Now, in this case, I think it's easier, and this is the way you'll find it probably easier. Let's multiply through by that common denominator, which in this case is 5. But remember, you have to do everything here by 5. So this becomes 5x equals 3y minus 45. So sweet, we have an equation with no x's, no fractions at all. Let's flip-flop these. Equals, minus 45 equals 5x. And now add 45 to both sides. And we get 3y is equal to 5x plus 45. Divide everything by 3. And y equals 5/3 x plus 15. So remember, here they're asking just for our y-intercept. So when we slide back up here, you can see how number 1 is the correct answer. That's an easier way to solve it. So if we had started that way with this problem, x equals 2/3 y, x equals 2/3 y plus 8. Make sure it was right, yes. So here you can multiply this whole thing. Remember, this is the first problem. Multiply the whole thing by 3, and you get 3x is equal to 2y plus 24, and then solve for y. And you would get the same answer. But you have to flip-flop the x's and y's now. All right? Probably an easier way to solve for y. All right, so the next one is point slope form. This one is crazy easy. I don't have a lot of time. So simply, you're gonna find the inverse. So you have x plus 6 is equal to 4y minus 2. And And I'm going to cut my voice off now because I'm going to have kids coming in, and I'm just going to finish this one up. But this is easy when you're doing it in point slope form. Okay, so now in this case, don't do anything else. Just multiply both sides by the reciprocal. And we get y minus 2 is equal to 1/4 x plus 6. So easily, you can see how the correct answer is number 1. Okay, so try an exercise 6 on your own, and all of you are standing here looking at me, talking to myself, so I'm going to go now. Make good choices.